And welcome, students. As we get into our next unit on data and security, we're going to start off talking about this unit about big data. And really important to talk about big data because there's a lot of data collection tools out there today, whether it's using things such as, just search queries from Google or, various other different means, such as reward systems. There's a lot of data out there and there's a lot of analysis that can go into it. So this is a pretty big field out here. And we're just going to kind of scratch the surface of it just a little bit. So before you can kind of understand what is big data, we need to kind of define what is big data, because you may not have heard of the term before. If you have, great. If you haven't, that's okay. That's why we're here. Now, big data is a broad term for data sets that are typically so large or complex that traditional data processing applications are inadequate. We're talking about data sets that typically will be like when you're looking at the raw number of data, it's like gigabits or terabytes or petabytes of information. So it's a ton of information that is not humanly possible to sort through. You're going to want a machine to try and analyze it. Now, because there's so much data within these sets, big data is usually used to do things such as analyze trends, patterns, or behaviors in order to help predict or model certain sequences or events. It could be like the next volcanic eruption, for example, because it can quickly analyze a bunch of data really quickly comparatively if you have a bunch of humans who have to go through and work through the mathematical models. The big data sets are very good at doing a lot of things, but they're not completely accurate either. So you shouldn't rely on big data for everything. We'll talk a little bit about that. So let's start by exploring what big data is by looking at something called data visualizations to see how big data can kind of really work, because it'll really help us visualize this kind of abstract concept a little bit better. So what does the visualization show? So what I have here is I have gone to Google Trends. You can just fire that up in a browser here, and you can see I have searched for the term iPhone. And this right here shows the interest over time over the past 12 months, and you can see that there's a spike right here. All right. Other than that, the search terms have kind of remained relatively steady, somewhere around here. If you notice, this right here is right below the 50% mark, and that's usually kind of where it holds. And you have a little bit of a spike here and there in terms of the interest. You also have interest by subregion, so it can actually break it down to tell you where's interest coming from. You can see there's a lot of interest coming over here from Hawaii. All right, so Hawaii apparently is very interested in knowing about iPhones. And then I can also, scroll down to give me like related topics and stuff like that. But let's just look at this one here, and we can change this from, let's say, the United States to worldwide. And you can see worldwide, the term iPhone also still kind of has a very similar pattern. All right, there's a nice big spike right here. All right, so let me just go ahead and put this back onto the United States. And let's just analyze this instead of the past 12 months. Let's just see this over the past 30 days. So I can really hammer in on how much I want to look at. So this is just over the last month at the time of this recording. You can see that this line has been holding pretty steady here. All right. If I go ahead and change this, let's say, to the past 5 years, because now I want to see a big picture view. So if I do the past 5 years, you can see there's a series of steady spikes here. All right. But you'll notice that these spikes over time, even though they're still happening, are perhaps a little less pronounced than they were right here. Right. So this says there's a note right here that proven to our data system was applied in January 1st of 2016. So some of this data that's a little older with Google's analytics here could be a little bit more inaccurate because they said they improved it right here. So I could try to change this to a custom time range as well. Maybe I want to take this back to, since it's at 2016, I want to take this back to, let me type in that. Let's go back to, let's just do like a 2-year window here. And you can see here we still have these two peaks here. Now, going back to the slideshow, it says, what does the visualization show? Well, obviously, we're looking at the interest that people have in searching for the term iPhone. We can search, of course, for other things. So, for example, I can put a new search query right here. I can just type here and put a new one. Or another thing I can do is I can do a comparison. All right. So we're going to eventually do some conclusions here. I have some like these peaks and stuff like that. But let's just do a comparison. Let's just compare it against Android. because obviously Android is the competing operating system. So I can put Android in here, and you can see now there is a new trend line here. In comparison to the iPhone, it's not quite as popular. But if I were to compare this against, let's say, the Samsung Galaxy, which is another fairly popular phone. All right, so let's just say Samsung Galaxy. And search for that. And you can see that hasn't changed much either. If I add in, let's say, the S9, you can see it's pretty flat. All right, it's not really pulling out much interest comparatively. All right, so it's really interesting to see how these two products compare against each other. I could even search, for example, let's say the Google Pixel, which is a phone. So let's say Google Pixel product line here. All right, and so I can look, and you can see like this is the iPhone. I'm going to change it to smartphone. So let's do maybe Galaxy S8. Right, so Samsung Galaxy S8. You can see it's still, again, pretty flat. If I go ahead and change this to the past 12 months, you're not going to see much variance. If I do the past 5 years, again, in those comparisons, there's not much there. Right, if I just remove this completely, the iPhone filter, you can see that not enough data is here to be shown. So clearly this search term is not one that has generated enough queries, enough hits. Now I can of course compare two other things. So let's just say I want to compare Marvel to DC. Those are pretty, so let's just say Marvel, and we'll compare that to DC. Okay. I don't want that, Marvel. So I have Marvel to DC. Now these are just the search terms. So it could mean anything, such as like DC could mean like Washington DC. So you get a lot of more comparisons here. So if I specify this down to, let's say, DC Comics, right, you can see that the waves have changed and a lot closer. If I change this to Marvel Comics, you can see that they have changed. Now you notice there is a spike right here, right, in these two interests. All right, and I want to talk about these spikes and stuff like that. So I'm just going to go back here to our query of iPhone because we had some nice data to look at there. All right, so here's our iPhone right here. So what can we conclude from reading visualizations? Obviously, we can see certain kind of patterns and trends that can happen over time. We can even look at where that data is coming from. So for example, if I want to search for, let's say, Little Caesars Pizza. So here's Little Caesars. You can see that here's the data trend, and we have this nice spike right here. All right. You can see, obviously, most of the queries are coming from Michigan because, obviously, Little Caesars is primarily situated here in Michigan. So you're going to have a lot of queries coming out of the state. Right? So data can really help us analyze where's the data coming from, what's the market, the demographics. There's a lot of stuff that you can do to kind of bury in here. So like you can see, like for example, city. If I change it over to city, you can see that there's a lot here in Detroit. You also have Westland here, which is also in Michigan, which is another big source of that. I'm going to go back to subregion. All right, and of course you have your related topics. Now, of course, we can also fill this into other things, such as different categories. We can also search like images and news and stuff like that, but we're going to keep it just on web search. Now, the thing that we need to look at when we're looking at big data is what's the cause of the spikes or the drops within the data. So I'm just going to go to Little Caesars and let's drop it back to just the past 12 months. Okay, so right here there's a small spike. Okay, so we have a small spike right here on April 1st to April 7th in Little Caesars. So what I could do is maybe I can look in the news and see, okay, what is in the news. And you can see it's not really anything that kind of corresponds. So you can see there's a bunch of spikes and stuff like that that happened for it. So I go back to a web search. Let's see if we can look for this Little Caesars. And let's see, April and that'd be 2018. All right. And so you can see there was a lunch combo giveaway here just by doing that quick promotion. So they had a promotion going on during that time. And so that's probably what resulted in the spike right here. Right? So little things like that can cause a huge fluctuation. So promotion and no sale, boom, it bumped that search query up because people are probably looking for information about the lunch menu, whether their store was participating, what the conditions were, stuff like that. All right, so all that kind of things can affect these different things. If we go back to our first example with that of the iPhone, we can see that there's a spike right here around September 10th to December 16th, 2017. So if we look for iPhone, and we just put in September of 2017, you can see right here, there is an Apple event, all right, Keynote 2017. So that's why there was a huge interest right here. So these spikes are very important to know that there might be something correlating to that event. Now, obviously, we can compare other things and we can draw conclusions and stuff like that. Like, for example, we might ask, okay, well, why is all of a sudden Apple stuff kind of been rather lackluster the last 6 months? You know, maybe it's because there's been no news, no announcements, that sort of thing. Those are all different kind of things that we can look at when we start analyzing big data. All right, so when we're analyzing these data sets, what I want to get into now is talking about a couple of things to look at when we start looking at these things. So we want to look for, first off, a trend. So is there a pattern over time? Whether that trend is like positive trend, negative trend, there's no correlation, whatever. We want to see what kind of behavior is that doing over time. So if we look at the iPhone, we can see that it pretty much, except for right here, has held steady around here near 50. If I jump this back out to 5 years, you can see that this data spikes, looks like. Here's in 2013, here's September 2014, there's a spike here in September 2015. So around every September, there seems to be a big spike because that's probably about when Apple does their keynote address. So those kind of things are very important to know and to analyze because that's a trend that reoccurs. Is there a correlation? Well, in this case, we have a correlation between September and iPhone interest. Now, what would be more interesting to see is if there's also a correlation between the number of search queries and the corresponding number of sales. So if we could see also the number of Apple sales that happened over the course of a year, then we could maybe correlate that the search queries relate to the number of sales. Doesn't necessarily mean it does, but it could be an interesting thing to look at. And the last thing, of course, are outliers, which are data points that don't fit in the rest of the model or set. So an outlier could be, for example, if I take this back to, let's go to past 12 months, right? So an outlier could be, for example, generally speaking, this trend seems to kind of go down, but then we have the kind of 3 data points right here that just are random spikes, right? Other than that, the kind of is continuing this downward trend. So we might ask and analyze, what are these outliers? What are they here? And they're skewing our data. All right. Now, information can be visualized in numerous ways. So when we're putting together our own data visualization from big data, it's usually key for us to search for patterns that are able to tell a story. And those patterns are things like trends, correlations, and outliers. All right. Also, when we're analyzing data, there's 4 different kind of things we want to look at. So what type of data set? Is it a quantitative data set? Which is data that can be counted or measured, right? So are we looking at, for example, something that might be like the number of something is a key thing you might see, or there is this many ballots cast in a local election. Those are kind of things for quantitative things when numbers matter. You also have discrete, which is numerical as well. All right, but typically it has a finite number of possible values. So a quick example is the number of employees in office. So let's say you surveyed, how many people. Let's say you work for a business, and let's say there's 10 people who work for a business. Well, the discrete data set is those 10 people. Right? It doesn't really necessarily correlate to anything larger than that local business, but it is a data set that you can work with within that business. You also have continuous data, which is data that's measured and has a value within a range. So, for example, rainfall per year. would be an example of it. You could also look at continuous data as things like, for example, let's say iPhone sales over the course of a year would be a good example of a continuous data set because it's constantly going, so you can analyze the whole thing. And then, of course, categorical, which is data that can be sorted according to a group or category. So if we started, like, for example, analyzing Android searches, right? Obviously, there's many different manufacturers of Androids and many different models. So we could, if we just looked at the Samsung series, we could start sorting the Samsung series into the different models and see how does that data affect things. Now, understanding these different types of data here affects how they can be visualized, whether it's like a line graph, a pie chart, bar graph, column graph, whatever, and how these things have relationships to each other. And remember, that's going back to talk about like trends and correlations and all that. Now, there's one last thing I want to talk about is when you're looking at data visualizations, which is some do's and don'ts, and then I'm going to find some examples here for us to look at. So when you're looking at data visualizations, typically you do want to use one color per category. You don't want to say, hey, every time I'm going to use this category, it's going to be a different color because it's going to get confusing to the reader. Generally speaking, let's say we're talking politics and we talk Republicans versus Democrats. Typically, whenever you see that, Republicans are red, Democrats are blue, because they're colors associated with those parties. And so it's easy for people to look at the data and analyze it. Number 2 says do order data sets using logical hierarchy. Logical hierarchy would be things like alphabetical, A to Z, or if you're doing numerical, it'd be starting like, for example, smallest to largest, or largest to smallest, depending on how it's going to be. You don't want to randomly sort things because it's going to be confusing to the reader. It says use callouts to highlight important information or interesting information. A callout would be this way, like a little speech bubble, something like that. Something to kind of draw the reader's attention to something that might be a side effect. So if you have like a column of text, you might have like a little bubble off on the side that's an important highlight, so people don't have to trudge through the big set of information. Also, you want to visualize your data in a way that is easy for readers to compare values. Like, for example, when we looked at the Android versus iPhone, obviously we were quickly able to find out that there wasn't really much information about the other search query, but there was a lot of information about iPhone. We can also use icons to enhance comprehension and reduce unnecessary labeling. So, for example, let's say we wanted to compare social media stuff. Well, rather than having to write out all the different names of the social media apps, we could just use their respective icons, which could help save us from having to, do a whole kind of labeling. Because, like, let's say, if you put the symbol for Facebook or Twitter up there, people are probably going to know, well, that's Facebook and that's Twitter, right? You don't want to use things such as high contrast for color combinations such as red-blue or red-green or blue-yellow, particularly because you can run into a lot of issues with people who might have color blindness, and so it can get very confusing because a lot of colors might be, having issues with themselves. It could cause different kind of problematic issues. Even for people who aren't colorblind, it could be just hard to interpret. You also don't want to use 3D charts. Because they can skew perception and visualization. 3D charts are nice to look at, but when you want to give a nice, solid data presentation, a two-dimensional chart is better because three-dimensional people might skew it to say, well, this is going to here, going past where it is because of the three-dimensional shape. If you have some kind of shadow effect on it or something like that. You also don't want to add chart junk, such as unnecessary illustrations, drop shadows, or ornamentations which distract from the data. So it's kind of what I just mentioned with you don't want to do shadow effects and stuff like that, because again, that's going to be a derivation to your data. There are appropriate times to use things such as 3D effects and stuff like that, but when we're talking about big data analytics, not so much. If you're doing like a little cute presentation with not a lot of data, it's not as big of a deal. Like if your numbers are pretty concrete, let's say you're doing like a number set from 1 to 10, it might be something that's a little bit easier. But if you're using something that we're talking like big data where you have millions, it could be an issue. Also, they say don't use more than 6 colors in a single layout because yes, while it might be awesome to use every color of the rainbow, it actually is kind of like a color overload to the end user. The person that has to read this would look at it and they might get a headache. They might just be turned off by your data presentation. So we want to try and keep color usage to minimal. 2 to 3 is kind of a good rule to use because it keeps, gives you a little variety without having it going overboard. And also, last point for for data visualization is don't use distracting fonts or elements such as bold, italic, or underlined. Keep it to your normal font, using things that are going to be non-distracting. It's like as much as people love Comic Sans is not necessarily the best font to use. All right, and now let's go look at data visualization. All right, so here's a quick data visualization, and you can see in this there are 2 different pieces here. So here I have a bar chart up here. All right, so a column chart, excuse me, and then down here I have some pie charts. Okay, so in this top one it says this is the number of smartphone users worldwide. So this is an example of big data because if you notice this is talking about millions of users. All right, and so in this chart I can go and analyze based upon those questions that I was asking earlier. So let me just kind of pop back over here so we can look at those questions. So what can we conclude and what might be causes or spikes or drops of the data? So we can conclude, if we look at this, what's happening to the data over time? Well, it seems that the number of smartphone users worldwide over time is increasing. What might be the cause of that? That would be something we could hypothesize. What could be the cause of this? All right, could be more people are getting more are buying more devices. The world population is increasing, so therefore the number of devices increases, etc. All right. If we look down here, we have time spent on social networks. We're talking about mobile versus desktop. All right. And if you look down here, you can see the keys. It might be a little hard to see, but the 68% is mobile, 32% is desktop here. We're looking at Facebook. All right, so that means the green right here is mobile, and then the white right here is desktop. And what's very interesting, actually, is when you look at these different apps, you can see where they correlate. So, for example, Facebook, Twitter, Instagram, Pinterest, and Snapchat are all primarily being used via mobile. Of course, you can see Snapchat's completely mobile, and Instagram, there's just a tiny sliver of desktop usage. When we look at YouTube and LinkedIn and Tumblr, you'll see that these apps are all predominantly desktop, especially LinkedIn. LinkedIn has a lot of desktop usage because it's a professional social media network, if you remember. So you're going to see a lot more of that. YouTube, obviously, you can browse it. You got people also using it for things such as video upload, streaming. So yeah, you can expect that there might be a little bit more desktop usage. Twitter, a lot of people are using that on their phone because it's easy to just do a quick tweet, share, photo, whatever. Yeah, you might have some desktop usage for some stuff, but you can see right there it is. So with that one, going back to our questions, what can we conclude? Well, here we can conclude those different points we talked about. Facebook, Twitter, Instagram, Pinterest, Snapchat, they're all more mobile presence. That would be an example of one thing that we can conclude. We can also conclude a lot more from this chart than that. So, for example, we could break down to the percentages if we wanted to. And what could be the cause of spikes? So here, if you notice, we're comparing different data sets. We're only looking at one snapshot. So it's a little bit harder to look at spikes or something like that. However, we could go and ask, for example, well, why is LinkedIn, as I mentioned, why is that one all primarily desktop? Well, it's because it's a professional network, so you probably have people doing more stuff from work, which is probably a desktop environment than they are necessarily from their phone. Whereas if I look at something like, for example, Snapchat, there's pretty much zero desktop use because it's only a mobile device. You have to have a mobile operating system in order to get to Snapchat, so that's the reason why Snapchat only exists right here. Okay? And I think there's just one more thing we want to talk about, which in terms of the different pieces here. So let me just go right here. So that is the characteristics of big data. So we've seen a couple different data sets. We've talked about a couple of different things. So we're looking at big data. You'll typically see these following characteristics, and these are important to keep in mind. The first of which is volume, so the quantity of the data. If I look back at this one here, you can see that when our quantities, we're dealing with millions here. All right, this one I don't necessarily have a quantity on. I just have percentages. But here I'm dealing with millions. So quantity of data is a big thing. So what's the volume of it? All right, a variety, the type and the nature of the data. So here I'm looking at the number of smartphone users. Down here, I'm looking at different social networks. what's the velocity speed at which data is generated or processed? Now this one, again, this is just a single snapshot, so it's really hard for me to tell about this one. So this one, well, this is some really cool data to look at. It doesn't really give me anything to care about. But if I look at the top one here, this one's really good because I can see that this data is happening yearly. So every year I get a new snapshot. Now if this one said like in like 2018, then that would give me a good snapshot of when this was, and I could actually compare that. Then I could go find what's the relevant comparison in 2017. But this one just says in mobile versus desktop, so I don't have a connotation for when the year was. And then veracity, the quality of the data which impacts the accuracy. This one, we would have to obviously see where's the sources coming from in this image. So what's the source of this data? All right, is this coming from, you know, the cell phone companies themselves? Is it coming from, let's say, sales off Amazon? What is it? You know, so we'd have to check the source. But if we look at this one's, well, this is a great source of data. This, I would argue, is a lot more accurate probably than this down here, simply because here I have years, and so the years I can cross-reference it. So I could like go to Google and it's like number of smartphone users worldwide in 2017, and I could probably find a source that could either verify or disprove that there was looks like 2,292.5 million smartphone users in 2017. So these are all very important things to kind of keep in mind when you start looking at these, because while this is a really cool set and I can get a lot of information from it, it's harder to verify information off of this just based upon what I have here than if I look at this one up here, because at least here it's a little more quantitative and it's a little bit easier for me to go through and do a cross-reference check. All right, but that's going to be about it for today, folks. So you guys are going to be doing your own data analysis. You're going to do some exercises, kind of like what we did, and you're also going to look at some infographics and get some information from them. So that's going to be it for big data for today. So until the next time.